Let's do section 9.1, page 445, number 17, which reads, the sequence in the exercise is geometric. Find A, the common ratio, B, the ninth term, C, a recursive rule for the nth term, and D, an explicit rule for the nth term. And our sequence is -3, 9, -27, 81, ... Now remember that that ... tells us that this is an infinite sequence. So the terms will just keep going as n approaches infinity. And we also have another clue here because we know that this is the geometric sequence. And the definition of a geometric sequence tells us that an is equal to an minus 1 times r, where r is the common ratio. And the whole point of being a recursive series is that the nth term depends on the term before it. Well, let's start by answering part A and finding our common ratio r. And we can use this definition and compare any two terms in the sequence. I think it's usually a good idea to just compare the first two terms. So we're going to have a2 is equal to a1 times r, right from this definition up here. a2 is my second term, which is 9. a1 is my first term, which is -3 times r. And to get the r by itself, I'm going to divide both sides by -3. And we end up with an r value of -3. All right. Well, part B asks us to find the ninth term. Now, we could use our recursive rule up here, which would mean in order to find the ninth term, we would need to know the eighth term. To find the eighth term, we would need to know the seventh. To find the seventh term, we would need to know the sixth, etc., all the way working ourselves back down to one of these terms that we know. Now, we could multiply that out, or we could remember the explicit rule that we just derived in the previous video. So that expression, if I remind you, is that an is equal to a1 times r to the n minus 1. Well, do we know what a1 is? Sure, it's that first element, -3. Do we know what r is? It's also equal to -3, and we found it in part A. So let's find a9. So a9 is going to be a1, -3, times r, again, -3, to the 9 minus 1. Every place that I see an n, I substitute in a 9. So I'm going to have -3 times -3 to the 8th. I have like bases here, -3 and -3, which means I can combine my exponents. I can add them. So I've got a9 is equal to -3 to the 9th, the 1 from this term plus the 8 from that term. And if you put that into your calculator, you're going to end up with -19,683 for that 9th term. All right, well, part C asks us to find the recursive rule, which means we're going to use this equation up here from the definition. So I've got an is equal to an minus 1 times r, and I'm just going to substitute in for r here. So I'm going to have -3, I'm just going to move it to the front, times an minus 1. So my nth term is equal to -3 times the element before it in the sequence. Part D asks me now to find an explicit rule, which means I want to use this equation here. So I've got an is going to be equal to a1 r to the n minus 1, and we can substitute things in. I know that a1 is my first term, which is -3. I know that r is equal to -3, and I raise that to the n minus 1. Well, just like we had before, we've got the same base, -3. So I've got -3 to the 1, and I've got -3 to the n minus 1. which means I can add those exponents together, and I get an is equal to -3 to the n. And that is how I can generate any term in this sequence without knowing the term before it.